Welcome. Our first baseline Tech Talk Tuesday is already underway, so let's jump right in. About the tools you need for two-wire overcurrent troubleshooting. It's really simple. It's not too many tools that you need. So the first thing you're going to need is a milliamp clamp meter. So I'll talk about these in a moment. So a milliamp clamp meter is one of the first things that you're going to need. The other thing that you're going to need is a known good solenoid. Nothing fancy about it, just any particular solenoid works. You're going to need a wire nut to connect your known good solenoid onto your wire path. And then lastly, you're just going to need a screwdriver. Those are the only things that you need for two-wire overcurrent. Now, that said, if you have the test leads that came with your overcurrent, with your meter, that's a bonus, right? Because now we can use this for additional things. But for the two-wire overcurrent in the field, that's all you need. So on the meters, I think it's worth talking about meters for a second. So people that troubleshoot conventional wire, where we have a common and station wire, we're used to using a multimeter or a volt-ohm meter, right? So it's a wonderful tool for conventional wire. It's not going to help us on two-wire. So this isn't going to work. So we're going to get rid of this. The other tool that we might be tempted to use is an amp clamp, but this is not a milliamp clamp. This is an amp clamp, and I have this one in my kit from lighting days when I work on low voltage lighting, or if you wanted to measure the draw on a pump, this is great, but it doesn't have the resolution that we need to find such a low draw on the two-wire path. So we're going to get rid of this one as well.
And Dan, when you say resolution, what do you mean by that?
So we're trying to read down to 1/1000th of an amp. So a milliamp is 0.001 amps. That's the equivalent of 1 milliamp. That's a really small number we're looking for. So if I have this clamp, those small little tiny numbers will be lost and it won't have the ability to see them.
Okay, so so we're reading at a point, the amp meter will read at a 0.01 and the milliamp will read at a 0.001. So you've kind of one decimal place further, 3 decimal places.
Yeah. Yeah. Now you may get 2 decimal points on a standard amp clamp, but even that, it may be doing some rounding. So these are small numbers we're dealing with, but what's awesome about it is this is going to be non-invasive, right? I'm not going to break splices. So the 2 milliamp clamps that I have that work, so this is a BK Precision 316. That's one particular model. I really like this one, but then I also recently started using the Armada Pro 95. Now, what's interesting about these, and I have these two up here, is you kind of think, well, it's about the size of the clamp. It's not. It's not about this clamp portion here. It's about what the meter can see inside. So let's fire this up and see if we can see it. So I'm turning mine to AC amps, and then we can see I've got, I don't actually have a reading right now, but I've got 3 decimal points on this amp clamp. And what I'm going to do is clamp it around the actual wire. So let's do one right now. So the way we're going to do this out in the field is on my wire path, I'm going to pick one side of the wire path, and we generally prefer the red side. And I'm just going to clamp around that red side like this, right down the middle, and I'll come up with a reading. Again, since I don't have anything loaded on it, I don't have a true load. We'll see that in just a moment. Now, if I had to pick between the two, I kind of said pros and cons. I see this in a lot more distributors. There is a benefit on this one, is it has a smaller nose, but I like the feel of this one, so I'm kind of torn. But they're both great meters, and there's probably others out there on the market that will read down to that low resolution. Okay, so we've got the tools. Not a whole lot on there. Then the last thing to mention on this one is when we get our meter with our test leads, this also has a voltage and resistance, or voltage and ohms setting on this one. So I can use this to test fuses, to test my power coming in. So this is almost a catch-all, where the multimeter that we're so used to using on conventional wire isn't going to be any helpful on two-wire systems. So let's jump into a few slides that I have. I'm going to show you what I've got going on here. I'm going to share my screen. So a couple concepts to keep in mind on troubleshooting is, the first one is to verify the problem that's out in the field. So if you have an employee that comes to you and says, hey, this is what's going on, you need to go see that with your own eyes. You need to make sure that they're seeing what you think they're seeing, because if they describe it one way, and in fact, that's not the case, you could be going a whole different path on your troubleshooting issue. The next thing to do is to isolate that problem. So is it a hydraulic problem? Is the problem in the wire path? Is it in the controller? Figure out where this problem is, because hydraulic versus electrical, that's a completely different set of tools. Then I think it's a great idea to start from the controller and work your way out. So back in my, I'll have to admit this, back in my early years of being a technician, I started working out at the valves and then came back and checked the ball valves. And then I just kept working my way back and got all the way back to the controller and found that someone had shut off the power to my controller. So that was 4 hours that I wasted that I didn't get back. Whereas if I would have started the controller, I would have found, oh, my power supply is out. And then that's a completely different problem. So, and then of course, get a milliamp clamp before you need it if you're working on 2-wire. If you're working on conventional wire, you can get away with the multimeter or voltometer still works. But if you've waited until you need it, now you're wasting time. So the 2 thoughts on a milliamp clamp is, if you send your employee out into the field without one, it would be the equivalent of sending them out in the field without a truck or without a set of tools, right? So they're going to waste your money and their time. And it just doesn't make sense. So for the cost of the meter, you're going to make it up really quick. Baseline support, and that number's on the door of every single controller. We always suggest that people add it to their phone, just put it on speed dial. And when you run into problems, give them a call.
Yeah, and I'll just make one comment as well. It's like, what's the expression? Like when it rains, it pours. So when people need support, sometimes everybody needs support. And so I'll just make a recommendation that if you would please leave a message, support does actually call you back very quickly. So can become common for people to call everyone at Baseline that they know. And just, if you leave a message, it works really well. Our guys will call you right back.
Right. Yeah, absolutely. I'd have to agree with that. What's interesting here is in the West, and then the Southeast, so Florida and California, Arizona, we can, in the middle of the winter, we can call because we're still irrigating, and we'll get people on ring 1. Wait till startup season for the rest of the country, and there can be a callback later on. You'll also find information on the Baseline Systems webpage too, so don't discount that. There's some really good resources on there. So I was looking at a controller the other day and saw this 2-wire overcurrent error message, and that kind of puts the fear into a lot of people, and it probably should, or it should be cause for concern, because when you see this error message, you're not watering. Nothing's going to happen. It's such a serious issue that we need to resolve it before we do anything. And there's an excessive draw of energy or a short somewhere out in the field, and that has the potential for damaging the controller. So an overcurrent, or this excessive draw of energy, could occur in a couple of places, right? So it could occur anywhere on the wire path. So we could have a red and a black wire touching, or intermittently touching. Maybe they're just rubbing together in some places. Maybe
Dan, when there's this overcurrent, can you still water? Does the system function? What happens to the control system in that overcurrent status?
So in that overcurrent, when it reaches that overcurrent status, we can't do any watering. So it can be quite urgent, especially if this happens beginning.
So the controller basically shuts down.
Right, because it has the potential for damaging the controller because there's a short out in the field. And we don't want the controller to be damaged, so it has that shutdown in the shutdown mode essentially. So let's say someone had misspliced this splice here, and the red and black were touching in a splice, that would cause an overcurrent. If someone had put a shovel through the wire and the red and the black are touching, even intermittently, that's an overcurrent. If this device here, if this bicoder failed inside, there's an internal short, that would cause an overcurrent. And then lastly, we could have an overcurrent perhaps in the controller. So I'd say it's more likely that we're going to, probably more typical that we see them in wire path issues. Would you agree, Andy?
I think so, yeah. And is it safe to say that an overcurrent is basically the two wires and the two-wire path touching each other, either in a valve box full of water that's being connected, or in a failed device, or in a shovel? It's basically those two wires that are touching each other.
Right. Somewhere, somehow, a red and a black are making contact. Now, here's the important note, though, is so that those orange and yellow wires and with the white on the bicoder, that's going out to the solenoids. Those don't create overcurrent issues, and those will just throw an error message, and your system will continue to operate. You can ignore the messages, you can fix them, but that doesn't cripple your system. Or a two-wire, you got to fix it before you do anything else.
So overcurrent is a two-wire only issue. And I know that your sort of next slide, and as we go through, is mostly focused on overcurrent because it's the most troubling issue. It's the one that tends to lead people to get frustrated most quickly. What are the other types of error messages that our controller picks up that either are related to the two-wire side, or in this diagram or this picture related to the valve side?
So we might see a solenoid open or a solenoid short that would not be a two-wire issue. And that would be, well, for example, right now, there is no solenoid hooked to this device. If it goes to look, if it tries to turn this on and look for a solenoid, it's going to look for, 20, 30 ohms of resistance, won't find it and say, there's a missing solenoid, throw an error. If the solenoid is shorted or has a corroded connection, it would also throw an error there. Those are the other common ones. The other one that happens is when we have corrosion on the two-wire path and those splices aren't real solid, they don't have a good metal-to-metal contact, we might get the infamous error 7. And it's essentially a communication error. And that means that the device isn't able to communicate back with the controller. Since our devices are not just decoders, we call them bicoders because they're bidirectional. We'll send out a command and they get a reply back. If it doesn't get that reply back, or there's another communication issue, can have other issues, and those are even harder to troubleshoot, but they almost always come back to wire integrity and wire issues.
So fundamentally, it would be important to look at the message and specifically look at the words that are in the message to understand whether the problem is on the solenoid side of the system or whether it's a two-wire message.
Good point.
So if it's a solenoid message, we don't want to chase down taking apart two-wire splices.
Good, excellent. Because if it's a solenoid issue, you could actually ignore a solenoid issue and just say, I'm going to manually water it. Well, if it's a two-wire issue, you're going to manually water your whole site. So that could be.
So just keep in mind that the error message on the baseline controller will tell you there's a two-wire error overcurrent, or the device is no longer communicating, which is a two-wire issue, or
absolutely
whether it's a solenoid side, so that you can start your troubleshooting tree, if you will, in the right direction.
Absolutely correct. So there is a slight possibility that the controller could be the issue. So one of the first steps to do is to disconnect the wire path from the controller. And here I just pulled off the red side of the wire path. That's all we needed. And then what we'll find out, if that error message goes away, well, that means my wire path connection went away. So it has to be in my wire path. If that error message persists, it could be in the board, and then I need to talk to support and might need to change it out or do some other troubleshooting on the controller. So when I disconnect the wire path, that is going to lead to that next step. And that next step is where I'm going to take that solenoid with the wire nut. I'm just going to splice it into the red side of the wire path. So here I've got a wire nut on the red, and then going to the solenoid, and then the solenoid other side of that going to the red terminal.
And the reason, and Dan, can I ask you something real quick?
Yeah.
So when you disconnect that wire path, does the message go away immediately, or does it take some time for the message to go away?
It could take up to 2 minutes to go away. Usually it goes away. It depends on the timing on when it's catching the cycle of it, but it could be up to a full 2 minutes. So you may need to wait a moment to see if it clears out. Good point. Now, when I've connected on the solenoid, I'm going to give you two answers on this one. The short answer on why we're putting the solenoid is it's tricking the controller, and it's going to allow us to use the transformer that's built into the controller to do our troubleshooting on the two-wire path. The longer answer is it's putting some resistance on that 2-wire path where it doesn't normally belong, about that another 30 ohms, and reducing the amperage draw of our overcurrent issue. I think the thing that you all want to know is that I can use the transformer that's built into the controller, which is a wonderful thing. I don't need to have a dedicated external transformer that I plug into a power supply.
So if you don't have a solenoid, there's one out in the field you could use.
I've seen every contractor truck. There's always an old valve laying on the back of the truck. They can use that one. Yeah, and I used a brand new one for mine, but yeah, any beat up solenoid doesn't even have to have the plunger. We're just looking for that resistance. So now that we've got that connected on there, the next step then is to clamp onto the wire path with my meter. So you notice I'm set at AC amps. And the most important thing that we're doing is paying attention to that number that's right there, 0.247. So 0.247 amps or 247 milliamps. Now that I have that number, I'm going to go out into the field. And I need to know where my wire path is. And what I'm going to do is clamp. This is the number I took at the controller itself, that 247 or 247 milliamps. And I'm going to clamp at every splice as we go along. And in this case, I'm searching for a really big number. So that 247 is the big number. I didn't need to add anything up. I didn't need to know the device draw on each component. I'm just going to look for this big number to drop off. So another way to look at it is that interface between a large number and a small number. That's really where I'm looking for. So I've got 247 here. On the other side of the splice, I have 247. But on this branch, I've got 0.012. There's no reason to track this down because I'm looking for the big number. So as we clamp along, it might drop off a little bit, right? So this 245. The 247 and the 245, that's not a number you're going to see on your site. It's going to be dependent upon the number of devices you have and the wire length. So that's not a number that you may see that same number, you may not.
So the number itself doesn't matter. You're just chasing the highest number. So whatever they are, you're going down the highest path.
Right on. Perfect. So here, this soil moisture sensor draws very little. No issue here. This device draws very little. Still got a big number. I'm still going the right direction. Small number. Nope, those aren't the issues. Big number, still looking that way. This clamp right here tells me that this splice, this wire path, and all these devices are all fine. There's no reason to go down this path any further. Still got a big number. I'm still chasing it. Nope. This 017 on this side, that tells me that all these devices, this entire length, so it could be 1,000 feet of wire, are all clear. No reason to go down there. So when I come to the other side of the splice, I've got a 224. That's pretty high. This is where I'm going to stop. Now, at this point, I'm suspicious it's the device. What I would do then is disconnect this device, bring it back to the controller, and with no wire attached, only connect this device, and then I would see that the issue pops up. So what's awesome about that, right, is I used my meter. I used this device just by clamping around every single wire splice.
And you were only clamping around, let's just say, the red wire. You were not clamping around the red wire or the outer jacket, just the inner
hardest
wire.
Part about this is getting it into the valve box, right? Because if somebody didn't give you enough slack, you're in trouble. So that's what we've got there.
And Dan, what if it was a lightning arrestor that failed? We do have a question about whether we can see if the lightning arrestor is bad from the controller, which we cannot. But what if a lightning arrestor has failed?
So a lightning arrestor will fuse, and it would be as if the red and the black are touching. So your clamp will take you directly to that one device, and that's where it stops. Beyond that, you don't.
So in that example where you found the decoder, you may end up dead ending at a lightning arrestor that's failed. Right.
Absolutely correct. Now, we're talking about 2-wire, but there's also people that aren't using 2-wire. So if I'm talking about the 2-wire side, right? I'm not talking about the solenoid side. This solenoid side, that's traditional wire troubleshooting. So that's where you're going to use your multimeter and the like. but that's also similar to if you're using conventional. So here's our 2-wire board. And on this 2-wire board, this is essentially two 12-zone decoders in here. So that means everything that's attached to this wire out here is solenoid side. So it doesn't matter if I have 1,000 feet or 500 feet of conventional wire attached to this one, that's all solenoid. So, so because my 2-wire path is what, it's maybe this long inside
internal. So if you have a 2-wire message on a conventional board, it's going to be internal controller board problem.
Absolutely. Absolutely correct.
Okay.
Absolutely correct.
We got another good question here. When connecting or disconnecting wires from the controller, does the power need to be off, or do you need to power cycle after this has been completed?
I'd say it's always a good idea to disconnect the power when you're working on wire out in the field for 2 reasons, right? Is the 30 volts can hurt, right? If you get bit by it, it won't hurt. It won't actually hurt, harm your health, but nobody likes being bit by 30 volts. So I would always recommend disconnecting it and then repowering it. There's a nice little orange plug on the side of the transformer that makes it super easy to power cycle it if need be. So I would always recommend disconnecting it.
Okay.
Any other questions for us in there?
Not in the Q&A. Please, if anybody has a question and wants to ask it now, this is the time. We're coming right up on our 30-minute time allotment, and we'd love to answer more questions if you have them. I'm sure that you do. This can be confusing. Dan, when you're in classes, what types of questions do you see come up in regards to this? Because I know you do a good job of
Sure.
laying out circuitry in a room and actually doing a live in-person class.
So probably the one of the common things I hear about is what's the amperage draw on each of our devices, and that number is available on our website, but it's something that I've have never bothered to memorize, because when it comes to overcurrent, it really doesn't matter. The controller has said, I have an overcurrent issue, just resolve it. So what that true number is, I don't have to add up my devices. I don't have to do any math. I don't have to multiply it out. I'm just chasing that. Yours today it was 247. It might be 192. It might be, 307, whatever that number is. I'm chasing that all the way down the line. So I don't really care. So that's
and I don't know if we covered it, but should you, I know the answer, so let me just ask it. Should you disconnect your loops before starting this process?
Ooh, looped 2-wire paths. Okay. Yeah. Please don't loop your 2-wire path. It doesn't help at all. So hydraulically, a looped main is a good benefit, right? That helps water flow. It doesn't help anything on a wire, and it's just going to create issues when it comes to 2-wire troubleshooting. So the first thing that anytime you call support and they'll ask, do you have a looped 2-wire path? Yeah, I do. Cut it. And you're going to treat them as separate wire paths. So always separate looped wire paths.
Good. Let's see. We have a question about who can I call when I'm in the field? So that depends. You'll probably call whoever I would say whether that's your local distribution and the local support there, whether that's me or your local regional sales manager, or whether it's calling directly into baseline support, as Dan mentioned from the beginning. And the hours are 9 a.m. Eastern to 7 p.m. Eastern. And there's lots of ways to get a hold of us, and definitely always happy to help. We're getting close to that time period where our phones are going to be ringing.
Yeah, absolutely.
Let's see. Any other questions pop up here?
So let me show you one other thing that, so we've got, well, let's see if you got any more questions, because I've got one.
Yeah, keep going.
Thing.
We're okay right now.
Good. So one last thing that I wanted to show you, and that's if, here's my email. And if you send me an email, I can enroll you or any of your employees into our online learning portal. So at our baseline.learnupon.com, we have other training modules that are available. They range from, I think I've got a 60-minute course, and then I've got a 3-hour course that's broken up into segments. So just shoot me an email. And if you have one name, if you've got 10 names of people that you want to do online training, I can enroll them, and they will get pushed an email. So this is always out there. And if you don't copy my email, or if you think about it later on, you can reach out to your distributor or local baseline RSM, and we can enroll you as well. So know that that's always out there.
Mm-hmm. And then we hope to have a couple more sessions like this as we prepare for the spring startups. The first one, we would like to cover flow and hydraulic setup. So a lot of times we don't have enough time to do the learn flow, either in the fall or during construction. So it's a good time of year to do the learn flow while you're on site doing startup, as well as if you've made any changes to those zones. So we would like to go through the learn flow setup. And then another thing we can do together is firmware updates. So in the last almost 10 years now, we've moved from a version 12 all the way up to a version 17. And when you're out there in the field doing a startup, it's really a good time to update the firmware of the controller. So hopefully that'll be another session that we can cover together.
Beautiful. Excellent.
Let's see, we have one more question coming in. What is the process for warranty on bicoders and soil moisture sensors? Do I go to the distributor or go directly to baseline?
Andy, you want to check?
Sure. Yeah. I would say it does not. You could go either place. Okay. So we will either work directly with you on replacement and issue the RMA, or we can work through distribution. And if distribution, let's see, oftentimes the devices that come back are not always failed. So keep that in mind. And also keep that in mind if you're a distributor on this call, that we would prefer to either have support verify that that device has failed because they've worked with the customer before issuing credit. Because if it comes back to baseline and it's working just fine, we may ask you if you'd like us to send it back to you. So we'll work with either of you. Just keep in mind that we would like to try to troubleshoot the products before they come back.
Yeah, if you can not break a splice, that's a wonderful thing. Just leave it in the field and figure out really what the problem is instead of guessing piece by piece.
And some of these we may answer individually. Let's see, Dan has a question. He had a problem where one of the controller was resetting the programming all by itself. Any idea why this happened? And I'd say, Dan, it's hard to tell. If you want to call into support or call us, we can work with you on that specific issue.
Yep, excellent.
Yeah, good. Well, we are right on time, a couple minutes over. And really want to thank everyone for joining us. We may send you, like Dan said, a questionnaire about our time together and how we can improve and do better the next time.
Awesome. Hey, good spending the morning with you guys.
We appreciate your participation. Look forward to upcoming sessions. We'll keep you informed.
Awesome. Cool. Everybody have a good day.
Thanks all.
See you later.
See y'all.
Bye-bye.
Bye now.